This lesson, we're going to work on rate, time, and distance problems. You probably already know that the rate times the time you travel equals the distance traveled. So if I want to go 10 miles per hour, and I travel that for maybe 2 hours, I would actually get 20 miles down the road. Now, this, of course, is direct proportion and indirect. I could divide by the rate, and I'd have that time equals the distance divided by the rate. So we have all sorts of things going on with distance, rate, and time. Let's look at this question. Susan and Chris are going to meet for spring break in San Francisco. Susan has to travel 535 miles, and Chris has to travel 482 miles. Even though Susan has farther to go, they make it in the same amount of time because Susan goes 6 miles per hour faster than Chris. What rate, also speed, did both girls go? So, the best way to approach these are to make a little table, and let's put the rate times the time equals the distance traveled. Okay, let's see what we know. We've got two girls. Let's talk about Susan on the top and Chris on the bottom. What do we know? Susan has to travel 535. That must be a distance. And Chris has to travel 482. Even though Susan has farther to go, they make it in the same time. So I'm going to put a T. I don't know what that time is, but I know it's the same. So I'm going to put a T in both of those. Because Susan has to go faster, 6 miles an hour. So the rate, Susan's rate, must be a rate 6 more than Chris's. So we'll make Susan's R plus 6 and Chris's R. Now, how are we going to solve these? Well, the best way to approach these is, first of all, let's make two equations. We know that R plus 6 times the time equals 535. This is for Susan. For Chris, we know that her rate times her time equals 482. Now, there's several ways to do this. In fact, you might think I could distribute the T, and you could, and there's several things to do. The approach we're going to do is we're going to solve both of them for T. Do you agree? If I solve for T on this equation, I get 482 over the rate. For the other equation, if I solve for T, the time equals 535 over R plus 6. Now, we said the times were the same, and since the times were the same, and I have both of these equations set for T, the equations must be equal. So I'm going to actually set both equations equal to each other. It's really substitution, right? I'm really substituting this value in for this T. So let's do that. We have 482 over R equals 535 over R plus 6. Now, as you remember, we can do cross products. 535R equals 482 times R plus 6. Let's distribute. 535R equals 482R plus, and everybody check what is 6 times 482? and we get 2,892. From here, it's a linear equation, so we want to get our r's on one side and our numbers on the other. This will give me 353r equals 2892. 2892 divided by 53. Let's show our work here. And the rate is 54.566. So we'll put 54.56, or let's do 57. And that would be miles per hour. So let's go back. We wanted both rates. If we have, let's carry this up with this. Oops. Let's carry this up to our table where we can see. So if our rate is, and that would be for Chris, because Chris's is R, Chris equals R. So Chris's rate is 54.57 miles per hour. Well, we know that Susan had to go 6 miles faster. So Susan's rate is 54 plus 6 would be 60.57 miles per hour. Now you should be able to do 1 through 6, maybe it's 1 through 5 on your worksheet. Try them this way.